Today's lesson is titled Reflections. Your goals are to 1. Reflect points and shapes and describe their reflections, and 2. Verify that reflections take polygons to congruent polygons. Consider these two shapes. I would like to place the shape on the left, shape A, on top of the shape on the right, shape B. What should I do to shape A to transform it to shape B? Write your answer on your whiteboard. You may have said that I can flip shape A to get it to look like shape B. That is correct. However, this requires taking the shape off the board. Another way to make the shape on the left, shape A, look like shape B is to look at it in a mirror. For that reason, we can say that these two shapes are mirror images of each other. Mathematically, we say that the shape on the right is a reflection of the shape on the left. A reflection is another type of transformation. When you flip or reflect a shape, there are different ways to do it. Consider these 3 sets of images. Point to the screen with your finger to show where the mirror would be to give the reflection. Consider these 2 shapes first. This is our original shape. If we look at what happens in a plane, the mirror becomes a line. This line is called a mirror line. A mirror line is indeed a line of symmetry when you consider the original shape and the image as parts of the same picture. In this unit, you will mostly work with horizontal and vertical mirror lines, and will work on a grid. Draw the mirror line with your finger on the screen for these images. The mirror line for these 2 shapes would be approximately right here, shifted a little to the right. Both shapes are equal distance from the mirror line. Consider the set of images down here. Where would the mirror line be? Point to it with your finger. The mirror line for these 2 shapes would be a horizontal line. Equal distance from each shape. Lastly, consider where the mirror line would be for the next set of images. In this unit, we will not typically have mirror lines on a diagonal, but this is the case in this example. We can also reflect points in a mirror line. Let's reflect point A in the mirror line mirror line M. The mirror line has already been drawn for us. To do this, we can first draw a line perpendicular to M through A. Measure the distance from A to the mirror line M. Mark A prime the same distance away from the mirror line. The point A prime is the mirror image of point A. Mathematicians say that point A prime is the image of A under reflection. Let's review congruence. What do you know about the sides and angles of congruent polygons? Record your answers on your whiteboard. One thing congruent polygons have in common is that they are the same size and shape. We could label our first polygon A and our next one A prime. The size and shape have not changed. You may also notice that the corresponding angles are equal and the same order of equal. We can also label the vertices with letters A, B, C, D, and E. Now, let's perform a reflection of this polygon. Whoops, let's also get the polygon. You will notice if I reflect or flip the polygon through a vertical mirror line, like this, the vertices will change order. In our original image, let's call it A prime, the vertices go in a clockwise direction. A, B, C, D, and E. My mistake, this should be labeled A. Our transformed image or reflected image would be labeled A prime. You will notice that the vertices go in the opposite order, counterclockwise direction, A, B, C, D, and E. You will notice that each point is equal distance from the mirror line. For example, point B is the closest to the mirror line in both shapes. Point E and D are further away from the mirror line. You should also notice that the angles have not changed. To review, if polygon A is a mirror image of polygon B, then polygons A and B are congruent. For the next question, I would like you to follow along on your whiteboard. If you do not have grid lines on your whiteboard, do your best to estimate the distances away from each mirror line. To begin, draw a horizontal and vertical line as mirror lines. In one part, draw a right trapezoid and label it D, E, F, G. Let's try that together. Let's start up here. D, E, F, G. Please follow on your whiteboard. Now let's connect the lines. We have now completed step 1. Now, reflect our trapezoid horizontally to get D prime, E prime, F prime, G prime. Let's try that together. To reflect this shape horizontally, you must imagine a horizontal mirror line. Let's use the x-axis. Redraw each point equal distance away from the mirror line. You'll notice that point E is 1 unit away. Our new point E will also be 1 unit away from the mirror line. E prime. D is 1, 2, 3 units away. 1, 2, 3. Point F is also 1 unit away. We can label this F prime. Point G is 1, 2, 3 units away. 1, 2, 3 units away. Label this point G prime. Now connect your points. This shape is a horizontal reflection of our original image. Our next instruction is to translate our original trapezoid, that's this one up here, diagonally to get D star, E star, F star, G star. Remember that a translation is a slide, horizontally and vertically in this case. These instructions have not told us how many units to translate our trapezoid. 1, 2, 3, 4. 1, 2, 3, 4. Let's keep going a little further. 5, 6. Our transformed shape has now been moved diagonally from our original trapezoid. Lastly, we need to label this shape as a transformed image by changing each vertice to D star, E star, F star, and G star. Our last instruction is to reflect our original trapezoid vertically and label it D double prime, E double prime, F double prime, and G double prime. Let's try that together. To reflect our trapezoid vertically, we must imagine a vertical mirror line. Let's use the y-axis. Next, we will redraw each vertice equal distance from the mirror line. Point F is 1 unit from our mirror line. We will label this point F double prime. E is 5 units from the mirror line. 1, 2, 3, 4, 5. G is 2 units from the mirror line. We will label this point G double prime. Lastly, D is 1, 2, 3, 4 units from the mirror line. 1, 2, 3, 4. And it looks like we have made an error somewhere. My mistake, E prime, or our original point E, is only 1, 2, 3, 4 units from the mirror line. We will move that point. Lastly, let's connect those points. And now we have our new image reflected vertically. Let's look at one more example together. These two polygons are reflections of each other. Join the corresponding vertices with line segments, then use their midpoints to find the mirror line. So, what does that mean? If we look at a vertice where two lines join, let's find the corresponding vertice on the orange image. Point to it with your finger. Correct, it's up here at the top. Those two vertices are separated by 2 units. Our mirror line will be halfway. Let's find a few more corresponding vertices. This vertice here corresponds to this point on the orange image. These are also 2 units apart. If we consider this vertice, it corresponds to the opposite corner on the green image. These are 1, 2, 3, 4 units apart. Our mirror line would be halfway, 2 units. We have confirmed that our mirror line is here. Please try pages 51 to 53 Give me jump math book.